Mari Mari Pumolamien, Inche Doris Sáez Hueichapan, Piñén, Inche Kimelfe, Kimol Rucameo. That is a Mapudungu language, it's my culture. It's in English, is my name, and also I am associate professor at the Electrical Engineering Department, University of Chile. Thank you very much for being here to listen to me. And thank you to Claudia and Nigel for inviting me. It's a great pleasure for me to present this project. I'm very happy to be involved in this. This is a project of design of participatory model microgrid smart farm system for the Mapuche Indigenous Communities. This project is with the communities, two communities in the south of Chile, Huanaco Huanchuna and Jose Painecura. That is the main important actor in this work. And we work also with the University of La Frontera. This is in the south in the same region. And also we have the collaboration of the Waterloo University with Claudio Cañizares and Paul Parker that are involved in this work, and the National Cooperation Indigenous Development in my country, and support of the Ministry of the Energy. This is a development project, and I also would like to thank to my engineers that are working hard in the community. It's a field work in both communities. There are electrical engineer and also renewable natural research engineer involved from other faculty, agronomy faculty, supervised by the anthropology professor that is in the same proposal. And also we have students involved. Okay, now I'm going to explain the structure of this presentation. First, I'm going to explain the motivation, a brief summary of this project, the objective, the stage. Especially, I'm going to explain the participatory model for technological innovation. Later, the application to the Mapuche communities, where now we are working. And based on that, I'm going to explain the design of the microgrid, and together that, the smart system, the smart farm system that we are going to implement in that communities. And finally, the integration of the participatory model together with the microgrid and smart farm system. Well, first motivation is because the access to electricity energy in rural zone has strong impact on the local development. And also the problem is the extent, the main grid involves high costs and several issues. And microgrid now is present as a good alternative to solve this problem and supply these rural zones. We have experienced, this is a picture in the north of the Chile where we installed the first microgrid in Huatacondo. And now we are working with the Mapuche people. We have really a motivation, personal motivation, because we are Mapuche academics and Mapuche students involved, and also others that want to promote our culture through this technological project. The Mapuche people in the rural zone, you have a lot of immigration from the rural zone to the city. And this is a terrible problem because the family disintegration, because the young people migrate to the city for several reasons, education, health, and others. But Mapuche, the meaning of the word and the meaning of our culture is the people of the land. We need the land to live our culture, really. That is the main problem. If you live in the city, you cannot live your culture as in the countryside. And there is a gap between the Mapuche life wave and the Chilean society. There are different things that are not possible to live in our culture. We have a loss of identity, of our identity. For example, in some period of in Chile, the language, Mapudungu language, that is the language of Mapuche people, was really eliminated because the Chilean society promoted the Spanish as well, and it was not possible to practice our language in the school. And for the young people, it was really hard. They couldn't learn the language. Later, Now, at the moment, there are young people that want to learn again our language. That's me. I try to learn a little bit and less. And the other problem, the other advantage of the Mapuche culture, we have a strong link with our environment and renewable resource. We have a special worldview of our environment and renewable resource. That's the main motivation that kind of project based on renewable energy is good, and they said, okay, we want to do it with you. Then this project consists in designing a microgrid smart farm system for Mapuche people based on a participatory model. We consider Mapuche people because it's the largest ethnic group in Chile, 86%. And also because in the Mapuche culture, or maybe in the other culture, indigenous cultures, the community is above the individual interests. And for us, that point is important and is used in the design of the microgrid and in the design of the smart farm that I'm going to explain in more detail. And the project and the challenge of this project is to design this technological innovation according to the Mapuche culture. It's really challenging for us. Then the objective project is design a methodology to implement microgrids for energy supply in this community, and together that to install a smart farm system. In this case, consider two applications: management of irrigation water and a livestock monitoring system. What is the meaning of the smart in this context? We found this term, and we are according this term, sustainable management and accessible rural technology that exists in the literature and there are applications. We consider two applications in this case because the community said for them it's very important the animals in the Mapuche culture. You live the culture through the land and the animals. It's typical for the Mapuche, and not so many animals because we have small land really. And then you have to monitor the livestock because sometimes you can lose one animal and you can be poorer, more poor than before. That since is very important. And the other, you can monitor your animals because you want to know where they are and you can help to the neighborhoods. Okay, and the other problem in the zone, and the Mapuche people said it's the problem with the water. We have a problem with water, not so many wells, and the idea is to use the energy of the microgrid for some purposes as productive development. And one of the productive development in the zone could be the agriculture. Okay, and both applications defined and the microgrid itself will be for improving the quality of life for Mapuche people while promoting or strengthening appreciation of their cultural and ethnic identity. That's the main point of this proposal. Okay, the stage of the project, we design a participatory model for technological innovation. I'm going to explain in detail the technical social criteria for selecting communities. That is very. And then we elaborate participatory diagnosis. And based on that, we design the microgrid and smart farm system. And finally, we try to integrate the system. Okay, if the figure you can appreciate observe the architecture of this. The idea is to install photovoltaic panels, wind turbines. Probably in these two communities, they are connected to the grid. Then you see the energy and communication infrastructure. You can monitor the animals. Okay, the participatory model for technological innovation involves a lot of work with the communities as meetings, workshops with the community in order to elaborate maps of the needs where the community can say us what they need, okay? And in this, we emphasize a lot of this. We explain the technology, we work with them. For example, for monitoring the chips, you need to install some device in the animals, and you have to work with the community and decide if you are going to install the device in the air, so like collars. Okay, you can do that. You can elaborate maps with the community. Because at the end they live there. You can install a weather station there. Where we have to install a weather station, you can use mesoscale models with the climate condition, but at the end they know where you can find more wind or more solar radiation. Okay, that is really important. Okay, this participatory model for technology innovation was elaborated with, strongly elaborated with my colleague, anthropology colleague, that elaborate this methodology. The first point is select the community for this project. I'm going to explain later the selection because it's important in terms. Sometimes if you select a community that is so poor, it's really the first need is other, it's not the energy. And then you cannot work with them. Maybe they need food, they need other things, not the energy or not the productive development. Okay, but I'm going to explain more in detail. Later, you have to elaborate the diagnosis of social, cultural, economic, and environmental aspects of the community. You have to work with the community to know where are them, what are the needs of them, if they have a social participation of the organization, what are the active, productive activities that they develop, and others. Okay, later, really start to do it this in all stage. Oh, excuse me. In all stage, you have to work in this process, okay? And you activate at the end the social capital of the communities. Also, you work with the organization. You have to evaluate if they have traditional organization, they have organization with the government, how they work, the organization. And during the project, you can activate this more, okay? And later, or in parallel really, you design adoption method for the innovative technology. Well, proposing a solution, introducing this to the community. Later, you need a validation of the technology. Later, the community adopt and appropriate the new technology. For example, a good example is a device in the animals. You have to check this. You can design the device with the people, because the people maybe they have some constraints or requirements in the device. Maybe they prefer a collar, or maybe they want to install the device in the urn to monitor the livestock. It's really good to do it with them, because then you can come back to the laboratory, redesign the system, and then go again. And this is a case of the sustainable project at the end, because if they think that it's their own development, they feel that they can continue with them, okay? And this also is important, and it's a part of this, the same, the co-management project. This meaning we work with, they work with us as a university, the community work with us together at the beginning, and when we implement the microgrid and the smart system in the community, then if we can do as well, then they can have a self-management project. That is the objective at the end. To do that, we use a selection of field methods and techniques, ethnographic methodologies that base in interviews, deep interviews, surveys, meetings, workshops with the communities. Okay, later we have to evaluate the project, but the methodology for evaluating the project is not, is the evaluation of our team, okay? The evaluation from the community to our team at the university. That is really important to do it every 3 months, every 6 months. You have to be very connected if the team is okay, working okay for this project, because it involves people. And the people in the community have a lot of expectation of our work, okay? And finally, you have to evaluate the impacts of the project. This evaluation usually in that kind of project could be 5 years later, but it's better to plan the evaluation every year after the implementation. And how to do it that? You have to compare the impacts in the context of with respect to the initial state. Okay, the criteria for selection committee. There are some essential criteria, the community insular and rural. The level of poverty, that is so difficult and is totally different from the poverty in the city and the poverty in the rural community and the poverty in the Mapuche culture. In the Mapuche culture, for example, somebody is poor because they don't have some specific food, like mate and sugar, something like that. Or if they don't have heating, something to heat their home. That is a poor guy. But we travel to the community and share with the community, and everybody feel okay with their own things. That is so difficult to define poverty level. And also, of course, the energy resource is important to implement a microgrid and the system. Other criteria that we are working a lot of is the social cohesion of the communities. We need to evaluate the internal relation between them, the external relation, because these projects, the funds come from the government, and they have to work with the government also as a university. And we have to evaluate how is the relation with the regional government and so on, because at the end, we need a community with this advantage to face the next step that implies the implementation. And also the participation is important in both internal and external organization. And finally, we'll evaluate the demographic dimension, that means the gender, population mobility, age roles. What is important that? Because at the end, we need some people of the community work on the maintenance and operation of the microgrid and the smart system, okay? That is important to evaluate that, to select the community. And then using that, the selection criteria, the evaluation selection criteria, plus the environment, economic and productive aspect and social cultural aspect that is a key of this project, we can elaborate the participatory diagnosis of the community. Okay, but we are going to finalize, to end this at the end of the project, really. It's a long process using, as I mentioned before, surveyed, we visit each house in both community meetings, deep interviews, and so on, to do a good participatory diagnosis of the community. Okay, we are working, this is my country, Chile. We're working in the south of Chile, in La Araucanía region, okay? And we are working specifically in two communities. This is one near Nueva Imperial, and this one is other in the coast, José Painecura, Guanaco. And I would like to show this video that resumes.
A 11 kilómetros de Nueva Imperial, región de la Araucanía, se encuentra la comunidad mapuche Guanaco-Huanchún. Uno de los principales problemas que afecta a esta comunidad, integrada por 116 habitantes, son los cortes no programados y el alto costo de la electricidad. Pero esta situación no afecta solo a las 83 familias de Huanaco-Huanchul. Otra de las comunidades afectadas es Josepa Inecura, de Mapuche ubicada a 45 kilómetros de Carahue.
Cuando recién llegó la luz acá, nosotros estábamos todos muy contentos porque era la luz, era un avance para todo el sector. Pero a medida que ha ido pasando el tiempo nos hemos ido dando cuenta que no utilizaban prácticamente, porque nunca se nos preguntó a nosotros si queríamos la luz, dónde iban a instalar los postes. Nosotros tenemos muy poca tierra como comunidad y a eso ahora los postes están todos ubicados dentro donde nosotros sembramos.
Cuando llega el cobro de la luz, de repente chuta, cosa nada. Nosotros acá estamos pagando sobre 40.000 pesos, 43, 44.000 pesos.
Es con estas dos comunidades que un equipo de la Universidad de Chile y de la Universidad de la Frontera está implementando el proyecto Diseño e Implementación de un prototipo experimental de microredes para comunidades mapuche, encabezado por la académica del Departamento de Ingeniería Eléctrica, Doris Sáez.
Tenemos un equipo interdisciplinario, antropólogos, ingenieros, estudiantes, académicos. Es un trabajo en terreno, en realidad, con la comunidad y aprendiendo la comunidad. Queremos plantear soluciones de cómo utilizar la energía con ellos, ¿ya? Para el desarrollo productivo. Y el desarrollo productivo está alineado a la cultura. No nos va a ir a hacer desarrollo productivo que no esté alineado con sus propios requerimientos.
La idea es aprovechar la generación de energía en localidades aisladas, utilizando medios renovables, para hacer más fácil el trabajo dentro de las comunidades rurales, sobre todo las comunidades indígenas.
Es un proyecto positivo porque se está haciendo el estudio antes de ingresar con el proyecto. Y eso es bueno, porque si yo traigo un proyecto y no sé cómo hacerlo o lo traigo sin saber si va a funcionar o no, nuestras comunidades comienzan a dividirse. ¿Por qué? Porque no se está haciendo bien las cosas.
Yo creo que esto es una buena idea y un buen pronóstico para dentro de la comunidad de Josepa Inecura. Realmente yo estoy conversando con otras comunidades que también están interesadas en este proyecto. Aún todavía no lo han visto trabajar, pero una vez que esté funcionando, yo creo que esto va a ser bastante bueno para las otras comunidades.
Porque uno le entiende, ellos no entienden, ellos tienen tiempo, se dan el tiempo para estar, para hacer las cosas. Hacen las preguntas así como preguntas de trabajo. Y eso es lo especial, lo bonito. Que uno le haga lo que hace inmediatamente lo que hacen eso, así no se nos preocupa.
Lo que vamos a entregar al finalizar este proyecto es un estudio y es una metodología, ¿ya? Que pudiese ser replicable a otras comunidades indígenas, no solamente en nuestro país, sino en otros países, porque pensamos que si logramos encontrar la solución de cómo potenciar la cultura a través de la tecnología, vamos a abrir espacio a que este desarrollo se replique en otras comunidades, que sea respetuoso con la naturaleza, con la gente que vive allá, que este modelo participativo del que hemos hecho énfasis en todas las etapas del proyecto realmente se puede hablar de un impacto positivo al final.
Nosotros tenemos un enorme capital histórico ahí, dentro de la cultura mapuche, dentro de cómo hacen el día a día. Y ese es el que hay que tratar de preservar. Nuestros proyectos están orientados a generar tecnología, pero también tenemos que generar ese capital, o sea, tratar de preservar ese capital cultural que tenemos.
Es en el plazo de 1 año y medio que el equipo espera tener los resultados de las condiciones climáticas para avanzar en la implementación de las microredes, que complementarán el actual sistema de energía eléctrica con el que cuentan ambas comunidades.
Okay, this is a video with the two communities that we are working, Huanaco-Huanchul and Josepa Inecura, but I am going to explain the detail of Josepa Inecura and the design of the microgrid and smart farm for this community. This community is 100 from Temuco, that is the capital of the region. It's a Mapuche people, that is a Lafkenche, that's the meaning of the people of the sea. Especially in this community, there are not mobile phone or internet coverage, and the productive activity as agriculture for their own consumption. They have small livestock, also collecting seafood and seaweed. And they are connected to the grid, but there are several faults, interruption of the supply. And the fault takes times 2 days, sometimes. Okay, now based on the previous sections, I'm going to explain the design for this community in special. In this case, we evaluated the wind and solar resources in that zone. Based on that, we sizing the microgrid or applying the microgrid based on a Homer software that is typical for this system. I have some results of these measurements. We elaborate this profile for Josepa Inecura. This is a wind profile for winter and summer, a typical date, average of the data. We installed, as you see in the video, a weather station, on a station to measurement the radiation, the wind speed, and the other variables. And also we use, because we have installed this just 3 months, but also we have the mesoscala model that are typical you can use in Chile, because in other departments they developed the maps of the wind in Chile for a lot of places. Really, almost is covered Chile. You can have access to the wind speed map and the global radiation map, and we complete the data. Okay, and here we have the profile of the radiation. So radiation for winter and summer, we have better condition in summer in terms of solar radiation, and we have better condition in the winter. Okay, I have some details here, the distribution of the wind. We have to know that 75% over wind of 3 meters per second. That is important for us because the technology wind turbine that we are going to evaluate working over this limit. Okay, and now here we have the demand. The demand we have in this graph the demand per month. Okay, for this community, we obtained this profile from some surveys that are complemented with this energy consumption that we obtain with the distribution utility, from the distribution utility. And then we have this amount of energy, average of 65, and a peak of power of 9.5 kilowatt in this community. It was hard because we applied surveys for each house to obtain the profile per day. Now some data for the evaluations of economical evaluation of this project. You need some field condition, economical data. We evaluate for 20 years evaluations. It's important to know the price of the energy to sell to the utility that the people paid in that community. Is that price is almost double that of the price that we paid in Santiago, the capital, in the city. Okay, that is incredible. And also we have a new law that you can sell to the utility, or the utility can buy us as a microgrid at that price. This is very low. Okay, and the fault in this zone, this is there are a lot of problems in this zone because there are mountains, streams, and the frequency of fall is 43 per year. Okay, at the average time of 10 hours or 9 hours, and the maximum could be 3 days. Imagine if with your refrigerator, with the food, you can lose your food in that period. This is a complex problem. Okay, it's some best cost that we assume to evaluate the project. We assume some photovoltaic panels, wind turbine on 2 capacity, 10 and 3.5 capacity, battery bank converter and diesel generator 40 kilowatt in this case, and the total invest for each technology. Okay, why it's important that? Because we use this software Homer to evaluate the different topologies in terms. You can see here photovoltaic panel configuration or wind turbine, diesel generation, battery bank connected to the grid, converters that are required. And we assume some criteria. These are preliminary results, but the criteria is to increase the energy consumption without increasing the cost paid by the people of the community. Okay, that's the main. And using that criteria, we have this intercolored the configuration, the topology of this microgrid with wind turbine, photovoltaic panels, battery systems connected to the grid. Okay, here in this figure, we can show the production of the energy by month. And you can observe in the green color the energy supplied by the grid, the main grid, during the year. In the brown color, you can observe the energy supplied by the photovoltaic panel, okay? And also in the green color, the energy supplied by the wind turbine, okay, during the year. And also in the light orange color, you can observe a small amount of energy supplied by the diesel generator. That is necessary when you are connected to the main grid, because there are a lot of faults, okay? And you can see in the table, there is around 44% of the renewable energy you can use during the year. And you can also sell some energy to the main grid. Okay. Okay, using that data, we have now elaborated some topology. This is a preliminary result. And now we are going to test this in our laboratory. This is a new laboratory that now is working, unless this is an emulator of microgrid where you can test some condition of the microgrid, connected, disconnected, and balance, and other in terms of the electrical point of view, just to be sure that the technology that we offer to the community will be safe for them. And safe, and the main purpose of the project is to improve the quality of the service, okay, in this case. And we have 3 units here of 15 kilowatt, 5 kilowatt each other. And we want to study different topologies. That means if we use just wind turbine or we use a mix of them. And then to evaluate the performance, consider economic and technical aspect. We have some figure of this system, a really complex system that we are working on that in parallel. Okay, and I'm going to explain the smart farm system. Define why we want to implement this, because we want to use the energy and the communication infrastructure of the microgrid to design this part. That it will be for rural communities. We require wireless sensor network communication, and the component of this system will be 3. A wireless backbone that will be used for the real-time livestock monitoring, remote measure of the water levels of wells that will be used for the irrigation, water irrigation, as suggests this diagram. We apply this for Painecura, Jose Painecura Mapuche community. They have 352 livestock and 36 water wells that we need to use this information to design the system. My colleagues from the University of La Frontera in the same region, they have a lot of experience on that. And they define a communication coordinator installed here. Here there is a house that the community have for meetings and other developments. And in our side, as a microgrid designer, we think we can install in the same server that we have installed, for example, the energy management system. Okay? And the routers will be in the roads of the community, and then the device at the sensors in this case. Other diagram of this system is the coordinator. It will be installed in the same server as the energy management system. We are going to use a ZigBee protocol. We define this. We have been using it in the north of Chile in the other microgrid. The routers will be the backbone system, and the final device or sensor will be the power metering. Okay, that is important. Sensor for water levels, cattle location, and data display. Data displayed could be signal to the consumer that where you can say for example, tell us if the supplies come from the main grid or come from the renewable energy. You can send a lot of information to them, of information of the localization of the animals and so on. My colleagues and we are designing this, for example, to send the information to each home, or maybe you can send information to your mobile. Okay. Okay. And finally, the integrated system will be incorporate the selection criteria to select the community, as explained before, using the participatory diagnosis, the idea to incorporate all the aspects, technical aspect, cultural aspect, and the others, in order to define the requirements and the constraints. That is really important to define them with the communities. And based on that, you can design the microgrid prototype and the smart system together in an integrated system using the participatory model. That's the main issue. And the microgrid, of course, will cover the energy requirements, also consider the whole aspect. At the end, we want to have a final product that's a methodology or model of the microgrid smart farm and participatory model to be implemented and replied to other communities, indigenous special, because we want to consider the ethnic and culture of each community that could be replied in other communities in Chile or as well in other countries. But what we, as we team, we are a team, Mapuche team, and the others that collaborate in this, we have our vision of this project. We think this project is not short-term project, it's a long-term really. It's for 5 years, or maybe 50 years more, why not? The point of us is to have a land or countryside, very technological countryside, really where we can develop our productive activities, work there, and also develop our culture, that we need our land to develop our culture. It's not possible really in a form in the city. That is our vision of our team. But what they think the community. Chaltumay, thank you very much. Yes, we include, this is a low profile of the community at the moment, but in the evaluation we include, of course, the increasing factor, of course, based on the smart system We are going to, the community probably is going to use more energy in terms of pumps. Yes, yes.
What kind of factor?
We include the factor of the using the rate of natality in the zone. Okay, we use also include I don't know how to say, but we increase the rate of increasing the population increasing. Okay, also include the pumps that we designed for the irrigation water system. You need pumps, and you have to include that. Well, the communication system is not really important, the energy supplied.
Now, for these expectations of community growth and energy growth, do you use some surveys, some historical data, or how did you come up with these values? Or
Okay.
just estimate them?
Yes, it's a good question. At the moment, we don't estimate that, the expectation. We did that in Huatacondo, really. In the north of Chile, we have experienced that. But at the moment, just we ask surveys about use of electrodomestic and so on, not just all. We have to go again and ask a question about the expectation, but we think it's not necessary go each house. We are elaborating out or planning workshop or meetings with them, a specific work meeting, to design, for example, a smart farm and the expectation of the energy in the future.
Because I'm asking this question because
Yes,
of
yes,
your
yes.
experience in Huatacondo.
Yes.
In the Huatacondo, the expectations were more than exceeded.
Yes.
People returned to the community, now they have businesses that were totally unexpected. So you did not have that in your plan.
Yes. That's the reason we can use that experience in that.
So you're using that.
Yeah, yes, of course.
Now, my second question was regarding the selection of the community. With all these interactions with the community, in two communities, they're creating a lot of expectations. And at the end of the day, you have to select one. So how are you going to deal with that issue? Because that's going to create a lot of people are going to be let down, and why not my community?
Okay. Well,
these studies, so.
It has been so difficult, but our team, when we work with the community, we say the truth. That is just in a study. We don't have funds now at the moment to the implementation. It's just in a study from 2 universities. But yes, but we have other strategies involved that we apply in parallel. We have been applied to other small projects to the community. For example, in Guanaco Wenchun, this other community that couldn't show so much, we apply with small project to try to implement the smart system that is a monitor of the livestock, and we hope to obtain the funds just to leave something there. And in the other community, in the Josepa Inecure, we are very happy because we obtained a new project from the Ministry of Energy in order to implement a small microgrid really in a house where they organize their meetings. And now we are going to start to work with the photovoltaic panel, install the wind turbine in a small sector of the community. But it's a hard problem, really.
How are you going to pay for this microgrid? I guess it's not part of this project, something that the money to pay for the microgrid.
We have to apply to the second step of this funds. FONDEF project, it's in two stages. We apply to the first stage. We obtain the funds around $400,000 at the moment, just for study to the communities. And we have to apply to the second stage. We have to attain that funds in the second stage.
What was the cost you're planning? You had a estimated cost
of the microgrid? Yeah. It's around $400,000 at the moment with these preliminary results. Okay.
No, 400,000 for the devices, for the solar, for all that?
Yes.
So that's
$400,000 at the moment. No, we include battery banks in the system. And well, you asked me two questions really. Well, we can include we include in this topology, pyramid topology, the battery banks, and of course we can share from the grid in some case. But could be to increase the reliability of the system, but we want to use, and the people in the community want to use renewable energy, really. Because the culture is, it's related with the environment, with the use of the sun and wind. It takes a lot of sense for them to use and to be a little autonomous from the main grid.
So they feel better if the energy
Yes,
comes
yes,
from the
yes,
wind
yes.
rather than...
Yes, that's the point. But we evaluate, we can do it. In the laboratory, we can evaluate if the battery will be charged from the renewable energy or from the main grid, of course. The sizing of battery is the issue. Okay. The first point is in this community, they arrive in monophasic lines to the community. In my opinion, really, it's really hard because the government is not worried about that community. That's the main point. They, as you see in the video, they install the poles in everywhere, in the middle of the agriculture zones, without nobody talk about that. That was my point. We have a contract and we work with the distribution utility now at the moment. They send the data without any problems. They don't worry about 43 faults. They have faults because the materials, I think, of the lines of the transformer, it's not suitable for that zone. They are in the coast. They have problem with the oxidation. They have fault because the climate in the winter, it starts to rain and there is a fault. And nobody comes as soon as possible. They come later. In this zone, they have a lot of mountain streams and they don't have a mobile communication system. It's taking a long time. And the second question, we assume in this preliminary result the cost of the energy will be the same and the community will have more energy. That we emphasize a lot of we want more energy because we want to improve the agriculture, other activities. Okay. We are thinking in many things. For example, involve the communities. Some of them can do some basic maintenance. But the key really is the distribution utility, I think, and the Minister of Energy. They listen us and say, okay, it's a good project, because they have a lot of problem with the communities, really. Imagine a lot of complaints about the energy, and they think they can work with us. In the future, I think the Ministry of Energy have to invest to solve this kind of project. In my point of view, it's personal opinion. The point is the rural zones of our country, it's really important for everybody. Because if not, everybody will be, at the end, living just in the cities. And somebody have to care our lands. And then, because of that, I think Ministry of Energy have to invest and have to have a section, especially of microgrids team, just to maintain the system. But I think the case, the community, we have to involve the distribution utility. We have been working with them. That's an open question, really. I don't have the... Okay, it's the high cost. This is a price that the people paid, that I say is almost double that in the city, because as we talk with the distribution utility and we analyze the bills, the points the faults, the cost of faults have to be paid by the consumers. This is incredible, okay? And the other price, okay? And the other price that we assume we can sell to the main grid or to distribution.
The nodal prices are very low in that area.
Yes, it's low. Yes, that's the point.
And aren't there any hydro resources in these communities, or only PV and wind?
Yes, there are others, of course. They can use maybe mini hydraulic, also biomass. But biomass is could be also used. But we defined in our team at the University of Chile, we have a lot more expertise with wind turbine and aeolic, wind turbine and photovoltaic technology. But we can extend to other technology, of course. We assume the distribution utility is going to work with us, because if we obtain the funds to install the microgrid, they are going to improve the distribution system.
Yeah, because that seems
yes,
like
I know.
a fundamental
Yes, yes.
problem that you have is
Yes.
distribution. You can
Yes,
generate
yeah.
with PV, you can generate
Yes,
with
yes.
hydro, you can generate with wind. But if you don't solve that distribution problem, that's one of your fundamental issues, both from a cost standpoint and from an interruption standpoint.
No, of course. We assume the utility will work with us and improve the distribution system to implement the microgrid, because if the distribution system is bad, we are going to have the same problem with the microgrids.
Yeah.
Yes,
So
yes.
are there going to be discussions then and plans as to how that's going to be improved so you can lower the cost, final cost, as well as improve reduce the number of faults?
The idea is to reduce, probably if they improve the distribution system, they are going to reduce the faults with the main grid. But I said to Professor Caserani, the main motivation of this is to install renewable energy in that zone, because it's according to the culture, according to the people, they want to do it. And the government want to do that really because they have a lot of political problem with the Mapuche people in that zone, with the forest plants and with the other types of companies that pressure to the Mapuche people and then construct the lands. And that is a good idea to do that in
So it's just a way to pacify the Mapuche then? So just a way to pacify the Mapuche?
No, they are not going to pacify us. But I think for us it will be great to install this in Mapuche community, because my country, you can, in the television, it's just bad news about Mapuche people that try to have more land in that zone, and they fight with the forest, and just so bad news. I think that kind of project will be great.
I have a follow-up question on the same point. So we're paying very large cost here for the distribution system to deliver the
Yes,
power,
okay.
and it's an unreliable system.
Yes.
Did you think about designing the system so that it would be a standalone, nothing to do with the distribution system, microgrid that will stand on its own with its storage resource and capability? Was that feasible at all? Here?
It's visible, and it's according of our culture. Mapuche people will be very happy. It's an autonomous system. They really, the people in that zone, the people that are really Mapuche in terms of the culture is very autonomous. They want to do it like this. An solar system could be great for them. But we decide to do in that way because we want to replicate this in other zones. And in the region of the La Araucanía region, most of them are connected to the grid and they have the same problems. We think if the distribution system installed, we can work with the distribution system. No, but many Mapuche come to my office and say, I would like an solar system. Because it's according to our culture, is something autonomous. Okay, as I said before, I don't have really a solution at the moment. Just my guess is Minister of Energy have to evaluate this and say yes, because I think it's important to have people in the rural zones in our country. That's my main point. The distribution utility says, okay, because he had a lot of problems with communities at the moment, a lot of complaints. I think he's going to invest at least for the first microgrids, at least. But the business is, or the project, evaluation of the project have to include the social benefits. Yeah, it have to be evaluated in terms, you have people living there, care our land, and have to put some price of that. Have to be higher than the cost of the microgrid. I think that is the main point. And the Ministry of Energy, I think, have to be in charge of that and responsible for the long term of the system. In Chile also we have a lot of islands. And they invest there a lot of really, usually diesel generator, that's not really a good solution. But they have thinking, install microgrid in that islands, that is really cost. They do it because they need people in that kind of islands. And the same concept have to be applied to the rural zones. No, well, there is percentage that have a primary, secondary school. Few of them go to the university, but for example, there are some, we guess, in the future, the young people maybe return to the community to be in charge of the mountains. They happen in Huatacondo, in the north of Chile, happen. Young people return to the isolated village.
Are they involved?
Yes, in Huatacondo, in the north of Chile, there are two people that operate the system. Instead, when there are some faults, they start with the diesel or call to Santiago. They have some assistance from the university. And in the north of Chile, it's really a co-management system. In the south of Chile, we want to start with the co-management and then self-management. But the self-management have to be people from the community and also people from the Ministry of Energy or some entity outside.
Because if you want to be autonomous, then you need to develop the skills internally.
Yes. But in the north, we did something like that. We could, that is the point we analyze demographic dimension. Okay?
I see here, you have this economic data, you have discount rate, inflation, etc. So what was the result of this financial analysis? So is it making any money in the budget? How many years did you pay back the 400,000 that you mentioned?
Okay, because in the evaluation, I didn't show because it's preliminary, we assume that we have the funds for the inversion. And later we have a cost of maintenance that is higher for the community. And we assume they are going to have some return from the price but this is really low price. And we assume they are going to improve the productive, the agriculture, other things.
But generally it's not about the money, it's about the community after all.
Yes.
Okay, well, any more questions? One last question? If not, well, thank you, Doris.